So, after working my way through a lot of amplifiers in the last sort of month or so, I've had a fair few on the bench, and it was only really the last 3 or 4 I actually sort of went and did a proper power test on. So for instance, these Gemini ones, they just got a basic quick full power run for just a few seconds, just to make sure that they were outputting, I wouldn't even call it a full power run, they were just sort of turned on, signal applied to them, and just flip through the dial, make sure that the output was actually working. Had them like connected up to a speaker through a resistor, just so you could hear as you start cranking them up, it was still outputting. Then at low level I was like putting 0.2 ohms or something across the outputs just to test the protection circuitry and stuff. But anyway, so I've got this heatsink here, has got 4 100 watt aluminium clad non-inductive resistors on it. They're in 2 parallel pairs, they're 8 ohm each, so in total it's essentially 4 ohm, 4 ohm in series, so it's 8 ohm. It's bridged across the output. On these they're an odd amp, you use input 2 and volume control number 2 when you're running in bridge mode. I've got the oscilloscope hooked up, I've got the multimeter hooked up, and I've got a phone just playing a 100 Hz tone. Let me start that because it's not an overly long, it's just off YouTube actually. So, how powerful is this amp? It says just down there 5,000 watts. Yeah, if you actually read the box, there's some caveats about that figure. It gives that as a short-term figure. Can't think what it says it will actually do full power. But there's one sure way to find out exactly what it will do full power, and that is feed it a signal, shove it on a dummy load. Now I've got the fans from the output blowing across this heatsink just to try and stop it from getting red hot. It's going to need some airflow. Start cranking it up. Okay, I can just see clipping there. So interestingly enough, look, the clipping light comes on at about 57 volts. Yeah, I'm getting clipping about there. So yeah, I did think that when I had these on the bench that I was getting the clipping lights coming on and I was nowhere actually near clipping. Let's go the wrong way on that. So, 66 volts across an 8 ohm load is, and this is constant sinusoidal output power. So 66 squared over 8, it's 544 watts, call it 550 watts basically. 66.6. Yeah, and what point do the clipping lights actually start to come on at? So just about there. So if you was driving this, you'd think, you know, that was clipping, which I suppose is good in a way. It stops you driving the ass off of it. Calculator. 392, so about 160 watts before it actually starts clipping. Oh yeah. So yeah, that's the if we come around the side here, so that's just a dummy load. It is going, it's a bit spaghetti back there, but it is going across the output. The scope, you can't hook the oscilloscope up to both outputs because you'll be shorting one to earth through the oscilloscope. So you can see the black clip leader oscilloscope's going to the black terminal on the back of the amp, which is a 0V rail, and only one side of the oscilloscope is actually going to one of the outputs. So yeah, I'm only actually looking at the waveform on one output. But I mean, I could have put the other probe in. They should both clip at the exact same point. What I can do is get the other probe and just to make sure, can't I? So let's zoom in on the scope there. Yep. a bit easier to see clipping. So you can see, oddly enough, they clip in one direction sooner than the other, it would appear. No, it's just you know, it balances out. It sort of, if you look on the scope, it sort of switches around which one it appears to be clipping on. It sort of appears to be coming from here to here. Yeah, is that a trigger thing? You'd imagine it can't be a triggering thing, is it? Who knows? All manner of things. Like I said, when I was fixing these, the drive circuitry isn't quite up to the job of really driving high power amp, but yeah, it's clipping symmetrically on each channel, so that's a good thing. And yeah, anyone who understands how much power 550 watts is will realise that this is literally like putting my hand in front of a small fan heater. You think like a fan heater normally will be about 2 kilowatts on setting number 2 and 1 kilowatt on setting number 1. So yeah, because of the small area, the surface area on this and the amount of airflow over it, just in front of it where the air is coming, it's like putting your hand in front of a fan heater. Anyway, yeah, just a quick little power test video. So I wonder what the website says the actual power output of this thing is. So I'm just looking here, and according to their sales brochure or their tech specs, it reckons 8 ohm 2x400 watt RMS, no such thing as an RMS watt, but we know what I mean. 4 ohm 2x550 watts RMS, and 8 ohm bridged 1100 watts RMS. Well, no. It will, realistically, you've got to remember, music isn't just a constant sine wave. Even real bass heavy EDM stuff doesn't have a constant sine wave. It is still up and down to some extent. It gives the power supply a chance to recover. So I think if you was going to take that figure of 1100 watts bridged, if you said you wanted an amp that was going to be capable of pumping 1100 watts into an 8 ohm speaker, I still think you'd be asking too much of this, but you know, realistically 600-700 watts maybe with full power supply, short-term pulses of music. If you know, if you could take that figure of dissipation and then basically say, if we kept that figure going for an entire hour, what would it be? 700 watts is realistic. But yeah, if you want just constant sine wave power, you've got not as much as the sales brochure likes to tell you you've got. Of course, you don't know what level of distortion that is as well. I mean, if I go and wham this up to some level of distortion, what percentage is that? Who knows? But that's now 80 volts. And what is... where's my calculator gone? 80 times 80 over 8. See, that just became 800 watts, you know, but you can get away with some level of distortion when driving, especially bass, because, you know, the sort of sound pressure levels you're going to be talking as well, you're just not going to notice it. Then of course you've got to take in mind speakers are reactive load, so their impedance changes. And but anyway, it's a bit cool up here, so I might just leave this running and see if I can't generate some heat. So yeah, that was all just a random power test. That's all for now. Thanks for watching, and catch you again. Oh, and yeah, Happy New Year. This is how I'm spending my New Year. Hours of fun. This is interesting. I was just up here baking this a bit more after I thought I've done all my filming. And can you see what the multimeter is doing? Actually put the scope away. I've ended up hooking the scope back up to make sure what the multimeter says is going on, and that, like my meter or something hadn't buggered up. But look, the signal lights have gone out on the amp as well, and it only allows the amp to get so hot. I did notice when I had it in, well, I had them all in bits, they've got various diodes scattered like on the heat sinks, on the power transformer and stuff. And I noticed you've got like the thermal switches on the heat sinks which disconnect the output relays. They like trigger the DC protection circuit when they close. But the diodes, all I tried was like shorting them out, and they just completely muted the output. But when you actually look, it's sort of fluctuating now. It's just sort of rising up and down. It was going up to about 50 volts, then down to like 10. And like those fluctuations have sort of decreased, and now it just keeps hovering, so it actually like kind of self-mutes. I'm guessing you wouldn't notice it doing it so drastically under normal working conditions, because normal working conditions aren't a solid sine wave. But yeah, as it gets so hot, it actually starts limiting the output on its own. So I'm going to try driving it. See, I've got my drive signal flat out again now. Before that was enough to put this into heavy clipping. I'm not clipping yet, and yeah, you can tell there's like some muting circuit kicking in because it's making the. That could actually be because I've not got the scope lead earthed. No, nothing to do with that at all. It's just, yeah, it's like the mutants, and you see the output is now, look, the clip lights have gone off and the output is sinking, but because I drive it harder, it's reacting, it must like reach a very fine thermal equilibrium, and it shows like there's a thermal mass in the heat sink. So to start with, they get too hot, it cools down quite a bit, and it's sort of until it kind of, that circuit, whatever the time constant is, kind of levels out. But yeah, look at that. It has a self-protecting kind of muting mode. Obviously now like that you've noticed that it's severely muted down, but under normal operation, like I said, it would just dapper it down a little bit, and the amp would just carry on running away in the rack, and because it had done it so gently no one would really notice. But yeah, awesome, I kind of like that. Yeah, it's not even really getting that hot, but it is in standard form. Those XGA5000 and XGA1943s are being pushed hard. Now I rebuilt this with on-semi MJL, whatever they were, like real high spec, much higher power dissipation, so they can take the punishment a lot more than what was in here as standard. Yeah, of all the amps, this was the one that was totally bastardised and dead on both channels, but yeah, I just thought that was kind of cool. Anyway, so yeah, now I will turn the camera off and go downstairs and make a cuppa. So yeah, thanks for watching.